So we want to go over the solubility rules to determine if a substance will dissolve in water or not. This paper that you're looking at should look familiar to you. You've used it before. On the left-hand side, we have some of the polyatomic ions we covered this year. We had a whole lot more that we used. This is just part of them. On the right side is the activity series that we use to see whether or not a single replacement reaction would occur. And then this middle part of the chart, we used this early in the third 9 weeks in January when we were writing chemical reactions, and you had to decide would any of the products made be a precipitate? Would there be a solid or not? So the way the solubility chart, the way it works is broken into two halves. This top half tells you what dissolves, and that is called soluble. The bottom half tells you what does not dissolve, and that's called insoluble. But there's lots of exceptions. So the way this works, things that are soluble contain these ions. A lot of these are polyatomic ions, but not all. So anything containing acetate is soluble. There are no exceptions. Anything containing ammonium is soluble. No exceptions. Anything containing nitrate is soluble. No exceptions. And the list goes on and on. But then eventually you get to something like bromine or chlorine. So something that contains a chloride ion is soluble unless it is containing silver, lead, or mercury. Any one of these three would become insoluble. So if we had sodium chloride NaCl, that would be soluble. But if we had silver chloride AgCl, silver is an exception, and that would become insoluble. So NaCl is soluble, AgCl is insoluble because it's an exception. Containing iodine or sulfate, same thing. Anything containing sulfate, as an example, is soluble, but if it is strontium sulfate, barium sulfate, lead sulfate, mercury sulfate, those would be exceptions, and any of those would be insoluble. The bottom half of the chart pretty much works the same way, but it's just backwards. This time it lists things that are insoluble. So any compound containing carbonate is insoluble unless it contains ammonium or an alkali metal, and those would be soluble because carbonate is normally insoluble. And just in case you forgot, alkali metals are elements that are in group 1 of the periodic table. Group 2 was called alkaline earth. So if we look at anything containing phosphate is insoluble, meaning it does not dissolve, unless it is ammonium or an alkali metal, then those things would be soluble because they're an exception. Anything containing chromate or dichromate is insoluble unless you meet one of these exceptions. Anything containing hydroxide is insoluble unless you meet one of these exceptions. Ammonium, alkali metals, calcium, strontium, barium would all make hydroxide be soluble. So as an example, FeOH2, iron hydroxide, that would be insoluble, but one of these things, such as CaOH2, calcium hydroxide, would be an exception, and that would be soluble. And then same thing for things that contain sulfides. Insoluble, unless you're an exception, then you are insoluble. So I want to go through some practice problems, and that's real similar to you'll be doing on your assignment today. So I'm going to take this chart and I'm going to fold it so we can just see the solubility rules, the part we want to focus on. And then I'm going to look at these problems off to the side here. So if we take a look at this first one here, and we have ammonium acetate. Well, acetate is soluble, no exceptions, so I know ammonium acetate is soluble. Barium hydroxide. Hydroxides down here are insoluble. Barium is one of the exceptions. So if it's insoluble, but now barium is an exception, that means it really is soluble, so that would be soluble. If I go to iron 2 carbonate, FeCO3, carbonates are insoluble. There are exceptions, ammonium and alkali metal. Iron is not one of those, so therefore that is insoluble. Sodium hydroxide. Hydroxides are insoluble. Are there any exceptions? Yes, there's quite a few. Sodium is an alkali metal. Sodium is right here, alkali metal. Therefore, that is an exception, and therefore, instead of being insoluble, because we meet the exception, is going to be soluble. Rubidium nitrate. Nitrates are way up here. Nitrates are soluble, no exceptions, so you're soluble. Cesium sulfate. Sulfate is SO4. on the solubility rules right here. All sulfates are soluble unless strontium, barium, lead, or mercury. Who do we have? We have cesium. That's none of these, so the exceptions don't apply, so therefore it is soluble. Magnesium sulfate, SO4 is sulfate. All sulfates are soluble. There are exceptions, strontium, barium, lead, and mercury. However, we're magnesium, so we don't meet that, so therefore we are soluble. Chloride, zinc chloride. All chlorides are soluble, meaning they dissolve, except for silver, lead, and mercury. We have zinc, so we don't meet the exception, so therefore we are soluble. Zinc hydroxide. Zinc hydroxide is ZnOH in parentheses 2. Hydroxides are insoluble. There are exceptions, ammonium, alkali metals, calcium, strontium, barium, but zinc is not one of these, so therefore it is insoluble. Zinc phosphate. All phosphates are insoluble. There are exceptions, ammonium and alkali metals. Again, alkali metal group 1. Group 1 on the periodic table. But we're dealing with zinc. Zinc is not in group 1. Zinc's in group 12. Therefore, zinc does not pertain to these exceptions. Therefore, that one would be insoluble. AgBr. Br is bromide. Bromide is soluble, meaning it dissolves, unless except silver, lead, and mercury. We have silver. We meet that exception. Therefore, instead of being soluble, we're an exception. So we're the opposite. So we are insoluble. So we take a look at one more. KNO3, potassium nitrate. All nitrates are soluble, no exceptions. So that is soluble. And that's how you use the solubility rules to figure out will something dissolve